Hello everyone. This is a video tutorial on logarithmic functions. When you finish this tutorial, you will be able to evaluate logarithms by using their relationship to exponents, and you will learn about properties and characteristics of logarithms. So let's get started. We will first define a logarithmic function, then we will look at the relationship between logarithms and exponents, including their inverses. Lastly, we will investigate characteristics and properties of logarithms. A logarithmic function, as we will see later, is the inverse of an exponential function. The function f of x equals log base b of x is a logarithmic function with base b and is equivalent to b to the y equals x, where b to the y equals x is the exponential form of y equals log base b of x. Let's look more closely at the relationship between logarithms and exponents. When we look at the first four examples, we see the relationship between logs and exponents. 1 equals log base 3 of 3 is the same as 3 to the first power equals 3. 0 equals log base 2 of 1 is the same as 2 to the 0 power equals 1. 2 equals log base 4 of 16 is the same as 4 to the second power equals 16. And 3 equals log base 5 of 125 is the same as 5 to the third power equals 125. In the last four examples, we can use the relationship between logs and exponents to solve for the exponent. Log base 4 of 16 is the same as 4 to some power x equals 16, which is x equals 2. Log base 7 of the square root of 7 is the same as 7 to some power x equals the square root of 7, which is x equals 1/2. Log base 64 of 8 is the same as 64 to some power x equals 8, which is x equals 1/2. And log base 2 of 1/2 is the same as 2 to some power x equals 1/2, which is x equals -1. As I stated previously, logarithmic functions and exponential functions are inverses of each other. Let's see how. As previously discussed, two functions f and g are inverses of each other if f composed with g equals x and g composed with f equals x. If we let f of x equal log base b of x and g of x equals b to the x power, then when we compose the two, we see that f composed with g equals x in bullet 1, and in bullet 2, g composed with f equals x. Hence, logarithms and exponential functions are inverses of each other. These four examples illustrate the inverse relationship. Log base 10 of 10 to the third power equals 3, while 10 to the log base 10 of 3 equals 3. Log base 6 of 6 to the 8th power equals 8, while 6 to the log base 6 of 8 equals 8. The following characteristics are useful as it relates to evaluating and graphing logarithmic functions. The domain is 0 to positive infinity because the y-axis is the vertical asymptote. The range is from negative infinity to positive infinity. The graph has an x-intercept at the point 1, 0 with no y-intercept. If the base is greater than 0, then the graph increases from left to right. If the base is between 0 and 1, then the graph decreases from left to right. This illustration represents the graph of a logarithm in standard form. The black line represents the graph of a log in standard form when the base b is greater than 0. The light blue line represents the graph of a logarithmic function in standard form when the base b is between 0 and 1. The vertical asymptote is x equals 0 with an x-intercept of the point 1, 0. Let's look at general, common, and natural logarithmic properties. General properties are with regard to logarithms of any base b. Common and natural logarithms are standard and exclusive in American textbooks and calculators. Common logs have a base of 10. Natural logs have a base of e equals 2.72. Please memorize these properties. It's your turn now. This is the section of the tutorial where you get to practice what you've learned. Don't hesitate to go back and review to help you along in this section. Complete problems 1 and 2 and post your answers in the comments section below so I can see how well you're doing. See you next time. Bye.